Dear leaders, professors, and students, today I will explain our paper called Using an Ensembled Boosted Model for IoT Time Series Regression from 4 parts. The first chapter, Introduction. Since entering the 21st century, with the development of science and technology and civilization, the quickening pace of life, we follow the travel demand is becoming bigger and bigger. Strong ability in infrastructure in China has brought the rapid development of urban roads, greatly convenient for people to travel. However, the explosion of the number of cars has also brought great challenge to urban road traffic, leading to traffic jams, accidents, and other abnormal situations, which has brought great inconvenience and risks to people's lives. The traffic flow data itself has a certain trend and regularity, but due to the complexity of time and the heterogeneity of space, the data itself also has strong volatility in a short time, especially when some abnormal conditions occur on the road. The traffic flow data may change abruptly. With the development of machine learning, more and more machine learning algorithms have been used in the prediction of time series data. In this paper, we extract the features of the traffic flow data and then forecast the traffic flow data based on the modeling of the XGBoost algorithms. Through the traffic results, we judge the prediction accuracy of XGBoost for such data and discuss the influence of different parameters in XGBoost on the prediction accuracy. Finding out the parameter configuration that XGBoost algorithms is suitable for prediction traffic flow data. The second chapter, related work. In essence, the XGBoost algorithm is a math based on tree structure combined with a symbol learning, whose basic tree structure is CERT. The core idea is that in the input space where the training data set is located, each region is recursively divided into two subregions, and the output value of each subregion is determined. The criteria for delimiting molecular regions depend on the type of tree, and the square error minimization criterion is usually used for regression trees. The XGBoost model is also special GBDT. The idea is to grow a tree by repeat feature splitting, adding a tree at a time, in effort learning a new function to fit the residual of the previous prediction. XGBoost can customize a set of objective functions with the help of Taylor expansion. You only need to know the first and second derivatives of the loss function to find the loss function into a quadratic function of one variable to get the extreme point and the extreme value. The third chapter, methods. The traffic flow data used in this experiment is typical time series data. Specific acquisition and processing methods are as follows. At a node on the certain round, read the traffic flow of this section within 5 minutes. At a fixed time interval of 5 minutes, we use the traffic flow data of the past 406 days as the data set of XGBoost time series prediction. In order to enrich the feature vectors, we built some likes on the dataset, and the number of likes is the number of feature vectors in this experiment. The number of feature vectors not only affects the degree of fitting, but also affects the operation speed of the algorithm. Therefore, we should first process the data appropriately and select the appropriate number of likes as the features of this prediction. Usually in the time series state, typically built of 128 likes to machine learning feature vector. In Benson's 2018 paper, he tried to mold different amounts of legs in the XGBoost algorithm. He found that when the number of legs was 144, it basically covered all the useful feature vectors of the traffic flow data of the time series for the XGBoost algorithm, and the calculation amount was not large. Therefore, 144 likes were used for this prediction. The logical diagram shows the steps of our experiment. Extract the original data, construct the feature vector, and then send the feature vectors to XGBoost, and adjust the XGBoost related parameters to output the prediction results, and finally evaluate. The fourth chapter results. The prediction of time series is a typical regression algorithm in machine learning. For the evaluation of the regression algorithm, we choose MSE, RMSE, MAE, and R-squared as 4 indexes. The formula is as follows. In order to explore the influence of different parameters in XGBoost on the accuracy of traffic flow data prediction, we set several groups of different parameters for the XGBoost algorithm and made prediction under the same dataset. The predicted results are as follows. Booster parameters were used to select the base model for each iteration. GB tree is the tree basic model, and the GB line is the linear model. We found the GB tree model was more accurate in prediction traffic flow data. R-squared is close to 1. And max depth is the maximum depth of the tree, used to control the overfitting of the model. The higher the value of max depth is, the more specific model learning is. From the table, we can see that when max depth is 3, the prediction effort is the best. With the increase of the value, the prediction accuracy decreases. Mean child weight is the sum of minimum sample weights, which is used to avoid overfitting. When its value is large, the model can avoid learning local special samples, but it may also lead to underfitting. In this experiment, when the value of mean child weight is 3, the algorithm performs the best, and the value of R-squared is 0.9. We find that the high or low value of mean child weight will slightly affect the accuracy of prediction. An estimator is the number of the largest tree generated, and also the maximum number of iterations. The experimental results show that when the value of n estimators is 20, the prediction effort is the best, and R-squared reaches 0.9. where the number of iterations is between 20 and 50. The best effort is achieved. However, when the number of iterations is too large or too small, the prediction accuracy of the XGBoost model for traffic flow data drops slightly. Thanks for watching.